Hello and welcome to another video. And today we have an Asrock B450 Steel Legend on our board. And this, I don't know what is wrong with this board, but I can instantly see a lot of physical damage. As you can see, these two parts were broken off. And if you couldn't see, these are supposed to be sitting right here. So these are broken off of the DDR. They don't carry any pins, but they are essential in holding it in. So we will have to see what we can do about those being knocked out. And also I can see some pins being bent, especially down here. Let's see, down here, as you can see, pins touching. So we will have to also bend those back, especially one of those is a clear CMOS one, and if those are touching, it will permanently reset the BIOS and hold the board in a reset state. So let's bend them back a little bit and do the fine-tuning later, just for now that they are not touching anymore. And we will also have to take a look in the area where these were broken off, because there might be then physical damage there. So because I don't really know what is wrong with this board except the physical damage that we've seen, we will put a processor into here and see for the passive power consumption in order to determine in what state this board is. So we will be using a 2200G in here. Going to be using some RAM. Let's get the power consumption displayed. So, now we have everything connected. Let's turn on the power supply and see for the passive power consumption. Turning it on, 120 milliamps, that looks very nice. That is about what I would expect. There is LEDs on this part, but it's not illuminating. It might only be illuminating as soon as we turn this on. So because I don't see any problems so far with power consumption or shorts, we're just going to be going ahead to be turning this on. Let's put a postcard into here. This also has a TPM header, so I will be using my postcard that I have in the TPM header. So let's get a power button and a speaker also onto here. So let's now see if it reacts to the power button. We have reaction to the power button, but we have very little power consumption. You can see 650 milliamps. That means probably that some of our power rails are missing. And the one that I would expect most is that our V-core is missing. That might be due to missing DDR voltages. So let's turn this off once more. Let's get the DDR voltage tester into here and see if all of our DDR voltages are present. So let's zoom down here, get the passive power consumption on again, to press the power button, and let's see now. It seems like we're missing VPP. That would explain quite something. Okay, let's see. VPP is supposed to be 2.5 volts. That is missing there. Let's put it into another slot and see if we get any change there. If it's only the slot or the actual VPP is missing on this board. So let's see once more. See if in this slot also the VPP is missing. Yeah, it's also missing on this slot. Okay. So let's go under the microscope and have a closer look in the area where the VPP should be located, and go from there, see what we can see there. So this is our damaged area for the sockets of the DDR. And let's see, I would expect this to be VPP right here. So none of the components look damaged or anything. There's a little chip on that capacitor right there. Let's see if we have a short circuit there. So let's get the multimeter. into here. So I would expect that this would be VPP, and this seems to have low resistance. Yes, 6 ohms. Pretty sure our VPP is shorted if this is VPP. So I would expect that to be our problem. Let's see. Is there anything else that looks like it could have been VPP? But I don't think so. VPP should just be very close to the RAM sockets. So the VPP power good signal is a very important signal that that is necessary for the power up sequence. So we will have to see if either we have a short circuit via maybe some damage here, because as you can see, it took a hit right here. But this looks fine. All of the pins are still there. So I wouldn't believe that would be a problem. So let's see if I have a board view for this and see if this is our VPP, but I'm pretty sure it will be. So let's also check our input here. This is, I think, ground. No, this is then the input side, and this is fine. And this is then ground. Yeah, this is ground, and this is its input side. So the input side is not shorted. As you can see, there's a big plane coming in there, which is then the power. We have a lot of signaling, and you can see that one is the output going to that one. So it might be, but if it's one of the capacitors, I would expect like straight 0. Well, let's go into board view and see. So now in the board view of the spot, and this is the area. We have the VPPM, as you can see, connected here through this controller, an NB691GG.Z, an MPS controller 4.5 volts to 28 volts, a buck converter 6 amps. Okay, so question now is, what is shorted on here? What is connected? We have capacitors connected. We have a MOSFET connected. That is connected to 1.8 volts on this side. Oh, it creates probably 1.8 volts out of VPPM. So the driver is probably something. Yeah, there's a driver for the 1.8 volts that drives this MOSFET to create 1.8 volts. But that is not something that is connected to VPPM. And it shouldn't be. We shouldn't get 1.8 volts shorted to here, except if this MOSFET is like shorted, but highly unlikely. One of the things I can see now, that the VPPM is located right where we have our broken pins, and this is not ground. Okay, is this ground? This is not ground. None of these are ground. Okay. So question is it damaged by these slots, or maybe because of capacitors that should be here that might have gotten damaged? That can also be the case. And yeah, so we will probably have to inject voltage and see then what gets hot. We will physically inspect these also, just to make sure if that might be the problem or not. So let's have a good look here. But it looks fine. As you can see, we can see the individual pins, which might be the actual VPP pins, but they're not touching anything else. They're here like they're supposed to be. And also the capacitors that are connected on this line look to be fine. So no damage here to be seen, why this would be shorted. So now I have our thermal camera here connected to the phone. Let's zoom down in the area where we need to go, which is quite here. And let's go a little bit out so we can see the phone fully. Let's now inject 1 volt, so we will start conservatively. and see how many amps we're taking. And we're taking 3 amps. And you cannot see, I'm blocking the whole view. Okay. Let's go a little bit out, take off this, and let's see once more. Is that a capacitor that gets hot? 80 degrees. That looks like it's a capacitor that got hit, that is shorted there. I cannot believe it. Is this just a shorted capacitor on the VPP line? Have a let's zoom down on this here. Let's get the power consumption out, because that is not from the power supply, and have a look at this again. Yup, that's a capacitor. 130 degrees instantly. It's the second one from the bottom. Wow. Really? Just a shorted capacitor on a VPP line? Can this be that easy of a job? So, that would be a lucky one. Like Soren likes to say, this would be an easy pizza. Even though with mainboard repairs you don't earn as much as with laptop repairs, but still. So, capacitor in question is the second one that looks like it got a small hit. So, I'm not too sure if this is our original problem. This might have been caused due to the shipping damage that was here. So, let's get some flux onto here. Take our soldering iron. And with the soldering iron, getting some leaded solder onto here. So, let's now get leaded solder onto both of these sides of the capacitor. Really does not want to take any solder. Really doesn't like to take solder. I might have to scrape this a little bit in order to let this take some more solder, because as you can see, it really doesn't like to take the solder. Now I got solder on that side, but not to show off that side. Okay. Let's just blast it off of there. I will be taking some foil to protect the DDR sockets, that they don't get destroyed even further. So what I like to use is some aluminum foil tape that I put onto the sockets to protect them from the heat. And that should be enough right here to protect them, because we don't need it for long. Let's take tweezers. Let's now blast this capacitor off of there. Oh, don't remove the other capacitor as well. Let's get this capacitor in here. And let's remove the middle one. That should be fine. So the capacitor is removed. We should already be able to check the resistance now. Let's get the multimeter in here. And let's see now. And now we have high resistance. Oh, you cannot see. The software is not connected. Or were you all the time not able to see? Probably. But now we don't have a short anymore. And if I now take my probes and try to probe that shorted capacitor that I've put here on this side. There it was. For a very short second you were able to hear. There you can hear it. That capacitor was definitely shorted. So now we don't have a short anymore. The area doesn't look great, but it doesn't have to. And also the filtering capacitors that are there are good, but they are not mandatory. So let us remove this foil now. And let's see if now we have VPP on this board. So let's see now. Let's get the power consumption also into here. Oh, it's auto starting. Interesting. And it's already putting out postcodes. C0, as you can see. Is this going to go further than C0? Do we get post beeps? The CPU now is getting warm. Why is this auto starting? Very weird. Really shouldn't be auto starting. I do not get any beep codes. Let's see. Oh, and now the power consumption is low again. Only an amp. This is very weird behavior. Okay, let's see that again. And it's auto starting again, 400 milliamps. But it's reacting to the power button. 2.4 amps, but I didn't get any beep. Let's see. I will plug a keyboard into here just to see if we have any indication. So it's definitely not on because the keyboard doesn't have an indication. It turned off with 1 amp. And it reacts to the power button, so you can turn it on again. So this is very weird behavior right now. There might be some more knocked off component or some knocked off components here on this board that we will have to take a look for, because it's booting very, like it's trying to boot. We get quite far, but something is still very off here. And I cannot tell what it is now. Let's see. I expect that we have all of our voltages now. That our VPP now is running. So let's just confirm that. So let's turn this on. Yep. VPP is now running and now it's complaining about missing RAM because I just taken the RAM out. So we definitely do get as far as that. Let's once more in a different slot see if it wants to boot with the memory. So let's see. The passive power consumption is way too high. We still have like 400 milliamps of passive power consumption, which is way too high. And we're getting stuck somewhere in the boot sequence. I will have to take a look if I can find any knocked off components. I will especially be searching in the area of the VRM and the SIO. And if I find anything under the microscope, I will bring you back, because this is not posting. 2.8 amps, it is quite high, but it is static. And oh, it did. Oh, I think it posted. Hold on a minute. What? Because I just saw an indication on my keyboard that I had connected, and it seemed like we have post. Let me restart this board once more. Take another button and hit the restart set switch. Hitting the reset switch. Yeah, 5 amps. It's posting. There it is already. Yup. Let's see if this turns off normally. Hitting the power button. But there's 1 amp of power consumption. That cannot be right. Something is very weird here. It feels like some power rail is about to blow up. I will pause the video. Let me see if I find a short anywhere. Especially around the SIO, because this shouldn't be auto starting. And yeah, I will be using the thermal camera just to be sure that this board won't blow up. But it seemed to be that everything else is fine. It might also be a case of something related to the USB being shorted. But let me have a look. So currently the situation is very weird. I want to show you how this behaves when you just plug power into it. So I don't have my power buttons on there. As you can see, these are here. And if we now turn on the power supply, we have 300 milliamps of power consumption, which is way too high. And I'm not touching anything. Let's see and wait what happens with this board now. Let's also get this cooler into here. Let's see now. Is this going to... This was auto starting before. Yeah, there it is. And all of a sudden it auto starts. And now it's at 1 amp. And the weird thing is it's not on, but it's not off as well. Like, there's no indication on the keyboard, and there's also no post screen actually happening. So the post screen that you can see currently in the top right, that is still the stuck one from before. But this is in a weird standby mode where it's just starting by itself. This might be related to the BIOS, because if I now press the power button, you can see it actually starts up, and it's going through the startup routine. We're going to have an updated picture every second now, or we should have. Yeah, 4 amps, and now is the updated picture. Now the board is actually running. So if I now hit the power off switch, we go back to that 1 amp, which is really weird. So something is draining a lot of amps in standby, and it's pulling PS on low, which is very, very weird. I already checked the resistance between the clear CMOS header and also on the power button, and they both showed higher resistance. So I'm not too sure what is happening here. What I want to try is to reset the BIOS. So we're going to be taking out this battery. We're going to be shorting out the contacts of the clear CMOS header. So I will be shorting the clear CMOS pins at the bottom. So let's see once more if it behaves the same way. So passive power consumption. And this time it completely auto started. Like as soon as it got voltage. And is it actually posting? Because yeah, it's actually posting. Yeah, 4 amps. Yeah, and there it is. It's actually auto starting right now. Okay, let's see. Does it properly turn off? Hitting the power button. I said hitting the power button. It turned off, but it's at 1 amp still. Is it going to restart by itself? Because you can see the fan header is spinning, so PS on is being pulled low, which is very weird here. Let's see in this area right here if there's anything knocked off, because that is where PS on is also. So I just had a quick look, but there's nothing interesting there. So it will remain in this state, it seems like forever, where PS on is being pulled low, but it does want to work and it does want to boot up. I think we even could go into Windows here. Let's see. Let's plug an M.2 into here and let's see if it recognizes that. So turning the passive. This time it's not instantly starting. This time it has 450 milliamps. Let's see. Is it going to be starting by itself again? So 450 milliamps. Let's wait for it. Because I was also using the thermal camera, getting like a thermal image of it, and I couldn't see anything that was getting too hot. And now it's auto started again. Weird. And now it shut off. Is it going to start again by itself? No, it's at 1.1 amps. I will be looking around once more. So I'm currently looking around, but there's nothing really getting hot. There's like little bits of power consumption, but nothing getting like ridiculously hot or something like that. I might have to pull this off and the heat sinks also, just to be sure that there's nothing broken there anymore. Because this is very weird why this wants to auto start all the time. So the board yet again auto started, and it does go into Windows. So that doesn't seem to be a problem for it. As you can see, the M.2 is being recognized. It's going to prepare devices to go into Windows. And there's the Windows screen. So that does work without a problem. Interesting. Okay, let's see. Does this turn off? And back to being turned off. And now we only have 120 milliamps. What is happening on this board? Now we have normal standby behavior. Huh? 120 milliamps, just like it should be. No 1 amp power consumption, no 450 milliamps like it was before. Okay. Hitting the power button once more. And it just seems to be turning on just like it should. Going through the power up sequence. Now in the power up sequence. And it booted. Okay, let's turn this off once more. Let me quickly check while I have the opportunity to see that Ethernet is working. And Ethernet is working. That is very good to see. So let's hit the shut off button. So it shut down and we're back to 120 milliamps. Let's take off the power again. And let's apply it again. And now it's 120 milliamps again. Why is this board fixed all of a sudden? Why? Yeah, like, we had a short. That was obvious. But why all of a sudden now it just behaves like it should? 120 milliamps. Nothing special. Very weird. One more thing I want to see. I want to find out why this illumination is not working. I think there should be illumination. Let's take this off and see under there. Because if, for example, for resale value, something like illumination definitely needs to work. And also we have to find out how we're going to do it with the 2 RAM slots here. If we can fix them. So let's have a look now. I can see a connector cable. So let's take this off here. So there's only 3 screws that we need to take off, I think. This is not one of them. This is for the heatsink. This screw and this one at the top. So let's take these off of here. And it already wants to come off. Yeah, it definitely is connected to something. Let's see now. So there is a cable here that is connected to a strip. Let's see, can we remove that? Yeah, I was able to remove it. So let's have a look in the area of the connector if there's anything broken there. So this is the connector in question. And there seems to be everything fine here. Let's check that fuse if that is intact. So we are in beep mode. And that is intact. Okay. So this might be a software thing that we have to enable it in order to work. So let's see if there's like in one of the BIOS settings something that we can change for this to turn on. Is this the right orientation? Does it go? It only goes one way, doesn't it? Was this plugged in the wrong way, maybe? No, pretty sure this can only be inserted one way. Because as you were able to see, the green wire was at the very bottom. And at the very bottom, I would expect the red wire. But you cannot... Pretty sure you cannot connect this backwards. Can you connect this backwards? I don't think you can. No, you cannot connect this backwards. Okay, so it might have... that should be alright then. So let's go into the BIOS and see if we can activate that. Just to be sure that it's actually working. So let's see. We are in the BIOS right now. Let's see now. Where would this be? Let's take off all of these so you can see better. Where would this be hidden? RGB LED. Oh, it's just off. Okay, let's set it to rainbow. Is it going to be working? Apply RGB. Oh yeah, that's it. It was just turned off in the BIOS setting. That's very good to see. Let me get the overhead view again onto here. There you can see it's now turned on right here and also there. Looking very great. So that was just turned off in BIOS. I've not seen it that it was automatically turned off before, but seems like someone did that. So we will have to worry now about why or how to fix these the RAM sockets. So we will probably have to use glue, and we will have to see if those still work or not. So let's first fix this thing onto here again, because there's nothing wrong with it. It just had to be enabled in BIOS. So what I want to try is, I want to populate all of these memory sockets, and I want to see if they get recognized. Because if they do, all we have to do maybe is to put in the ends of these sockets and try to glue them in. So let's see if we can get a boot with all sticks of memory being recognized. And we might have an easier job than it first seems, because I do not have replacement sockets, and I do not want to unsolder all of them. So let's see now, get the power consumption in here again. So this looks like a normal boot up sequence. Let's see now, it's probably RAM training, because we have new RAM and there was 4 amps. So it's probably, we probably should get an updated screen every second now. Let's see now. 5 amps, yeah, that looks very good. I don't have my HDMI input. We will have to restart because we don't get a updated picture. Let's restart the board. And we now should be seeing every second a picture with all 4 DIMMs of RAM being detected. There it is. And let's see, let's show me memory capacity. There it is, all 4 DIMMs of RAM are connected. 20 gigs of RAM. That is very good, because that means that the DIMMs are fine, just the plastic needs to be glued back on. So let's turn this off. Let's get this off, this off. Let's get rid of the post screen. And let's have a closer look at what our situation is with the ends here. So we will probably have to go under the microscope for that. So what you can see, this is the end. The good thing is this is a non-movable end, so this is a fixed end that just has these 2 points here that go through the hole. And what we might be able to do is to put solder on both of these and fix them already in place, and then just put a dot of glue somewhere near. So I will have to find out which of these has come from which end here. Let's prop up the board a little bit so that I have room to put these through. Because what we need to do is to line them up so they are at least fine in there. Oh, you can see, that is very interesting to see why these don't want to go into place properly. The pins are bent outwards permanently. You can see I have these shakes, but bending them back in there and here, and we should be able to get this into a proper place. This might be the other one. Let's try the other one. Might be coming originally from here. Let's try to put that one in. If this is the actual broken part from here. But it doesn't seem like this is the original broken part. Let's see. Can I push them back in? That one. No, it doesn't seem like I can push them back in. Like, these are almost the finest tweezers that I have. But I cannot get this any closer here now. So this is not the one. I think this one was from the other side. And that this is the actual one that is supposed to be here. So, yeah, this looks more like it. As you can see, now the pins are more or less already where they're supposed to be. Let's see, can I push this one a little bit further in? Yeah. And now you can see this is the one that was here before. And if I could hold it like this and glue it down, this would basically already be like it's supposed to be. Just that one pin right here is a little bit out of place, I think. But it should be fine, actually. Yeah, that looks very fine, actually. If we get a side shot of this, yeah, that looks to be fine. I think we might get a good contact with that. Okay, so how we do this to prevent it from moving now? I would want to use some hot glue just on one side in the inner parts right there. But before we do that, let's see if we can get the second one in as well and just glue both of them at once. Let's see now. This one wants to a little bit less wants to sit where it was before. So let me see. Can we push these back enough for this to go back into its original space? So it's already a lot better than it was. But they move back a lot. What we might be able to do, let's see when we put a actual DIMM slot into here. So we now have a DIMM in here. And this is a very good guidance. As you can see now, with the DIMM slot in here, it actually guides it pretty well and holds it in place. So this would be great to use as a guide. Let's do that on the other one as well. Even though the other one holds pretty well, but there's nothing better to give it the actual position where it needs to be than having an actual DDR socket in here. Because as you can see now, this looks very fine. Like, these are broken, but it's just a plastic. So I will be using some hot glue now, and I will be applying some hot glue onto this side right here. And I will also, I probably won't be able to get it in between here. So I definitely, you know what we do first? We first solder them at the bottom. We put a big blob of solder onto the bottom so it doesn't, so it cannot move out anymore. Let's do that first. So these right here are the pins that we saw from the bottom mounts. Let's apply solder to them. So first applying flux to them. And let's now solder these up to have a big blob of solder on them. So they cannot move anymore physically. So we cannot solder them to the board. But what we can do is just solder to themselves and make sure that they physically cannot move out of here anymore. Let's do that on the other one as well. Apply a big blob of solder to here, so that the solder just builds a physical barrier of this not being able to move out anymore. So we're not going to solder it to anything. It's just going to be a metal barrier. And that's pretty much about it. Let's let it cool down, clean it up a little bit. Let's get some IPA into here. Clean this area up. So, these are now our two anchor points, as you can see, right there and there. And I think that might be already fine for us to use. Let's see now. Yeah, there's nothing to be seen on this side. It has moved a little bit, as you can see, by this one. Oh, but the plastic still moves a lot. Okay, so that isn't enough. It will hold it in place further, but it isn't enough yet. So I will have to find some solution where I can put glue on them. So, I think I will do this off the camera, because this is just now a job of putting glue onto here. But I'm very happy for this repair now. And all we had was a shorted capacitor on VPP, which is really lucky. Haven't had a shorted capacitor on that line before. And in the last few times, we get a surprising amount of shorted capacitors. Like on ATX mainboards, that is very rare. But it's a really easy fix and a really nice one for me. So, yeah. I hope you still enjoyed the video. I will be taking care of these DDR sockets, just gluing them down a little bit. And I hope you enjoyed the video. Hope you learned something. Thank you very much for watching. This was Main Mathematic. Thank you very much and goodbye.